How you doing tonight?
Fine.
Good. Okay, so we're going to do just a half an hour tonight.
Yeah.
Okay. Do you have some problems you can verbalize, or do you need to send me anything, or?
I have some problems.
Okay, cool.
The first one is the function d and then in parentheses t equals 1/2 t plus 6 models the depth d in inches of snow on the ground during the first 9 hours of a snowstorm, where t is the time in hours after the snowstorm begins.
Okay.
Graph the function and identify its domain and range.
So how do I graph this function? What's the very first thing where am I going to start?
I have no idea.
Well, what's the horizontal axis called?
The horizontal is x.
Actually, in this case, it's t.
Oh, yeah.
In other words, this is just like an xy function, only instead of x, they use a different variable. And in this case, it's t. And the y-axis is actually called d of t, which is also the same as y. In other words, whenever you have this kind of notation, that's the same as y. It's just more powerful. When I call it d of t, it's more powerful because it tells me it's a function of t. It's not a function of x. It's not a function of r. Not a function of any other variable. It's a function of t. In other words, whenever I see this notation, I know that the only variables I'm going to find on the other side of the equation are t. Okay? So where would I begin graphing this?
You would begin with 9 hours.
No.
Y equals mx plus b.
That's the standard format of a linear line. This is linear. In other words, it's not t squared, it's not t to the 1/2, it's t to the 1 power, which makes it linear. So in our function that we're dealing with, what is m and what is b?
M is going to be the time and b is the depth of the snow.
B is,
or do I?
M is 1/2. In other words, that is m. So whatever whatever the coefficient of the variable is, that's what m is. And b is the y-intercept, which in this case is 6. So that's always where I'm going to start, is at 6. I know that that point is on my curve. Now how do I graph the rest of it? I need one more point, because I know it's a straight line. Well, the slope is 1/2, but how do I get another point on this line?
You have to find out.
How do I make 2 points on this thing that have a slope of 1/2? If I go up 1, how far do I have to go to the right?
You have to go up.
Slope is rise over run. There's your rise, there's your run.
You'd have to go over 1/2 or 1 to the right.
No.
No, 1.
Up 1,
to the
numerator,
right.
And I would go to the right 2, the denominator. So whenever you have a fraction, slope is a fraction like 1/2, then it's really easy. There's your rise, there's your run. Always remember slope is rise over run. So I would go up 1 unit over 2 units, someplace about there, and it's okay to approximate that. And then I connect those 2 points, and there's my line. And that line describes this equation. Now, their question is, what is the domain and range, correct?
Yeah, the domain is time and the range is depth of snow. But if you're going to actually look for numbers,
That's
the
what they want,
domain,
is number.
yeah,
What is the effective domain? In other words, does this line go all the way to there?
no.
Why?
Because you can't have a
You can't
negative
have
amount of
negative
snow.
time. In other words, time, whenever time is the variable, then it has to only, the domain is always going to be positive t's only. T could be 0. What's the depth of the snow at 0 time?
It would be 2. No, 0.
No. Plug in 0 for t. What do you get for the depth?
0.
Plug in 0 for t.
You'd have 6.
Right. So what this picture tells us is that the depth is already 6 inches before it starts snowing. In other words, there must have been some snow on the ground already. Okay. Now,
Okay.
they're undoubtedly going to ask you questions like, what's the depth going to be after so many hours? What are the next questions that they have?
Interpret the slope and the d-intercept of the graph.
Okay, we've already done the d-intercept. That's 6. And
This,
they're going to say, what is the real life meaning of that, right? Well, the real life meaning of that is that at time 0, the depth is already 6 inches. What's the meaning of slope? What's the real life meaning of slope in terms of the snow, and you're sitting watching your TV and you want to know, well, how much is it snowing per hour?
for every 2 hours, it grows 1 inch deeper.
So it's 1/2 inch per hour.
Oh.
That's the meaning of the slope. It is snowing at 1/2 inch per hour. At the end of 1 hour, the depth will be 6.5 inches. At the end of 2 hours, you're correct. 1 more inch of snow will have fallen, and the depth will be 7 inches. But the real meaning of slope in a problem like this is it's snowing at a rate of 1/2 inch per hour, and you generally make it per hour, not per 2 hours.
Okay.
Okay? What else do they want to know?
That's it.
That's it for this problem? Okay, what else?
Yeah. Graph the linear equations, identify the X intercept. And the first one is y equals negative x plus 7.
What's the x-intercept mean?
The x-intercept is where it's x, basically. It's where
Hold on.
the line goes through x.
Well, there's a very specific meaning. First of all, we know the y-intercept is what?
It's horizontal.
7.
7.
That's B. Okay. Slope is -1, right?
Yeah.
Well, so this line goes like this. And they're asking, what is that point right there? Well, when you're talking x-intercepts, what is y? If you look at this graph, what's the y measurement when I'm crossing the x-axis? Very important concept in algebra. X-intercepts are where y equals 0, right?
Mm-hmm.
Isn't the y measurement 0 at that point?
Yeah.
Yeah, and y-intercepts are where x equals 0. So that's all you have to remember is that x-intercepts are where y equals 0, y-intercepts are where x equals 0. So in order to solve for this point right here, I want y to be 0, right?
Yeah.
Now I'm going to solve that equation. What is x equal to when y is equal to 0?
X is equal to negative 7.
Negative or positive?
Negative.
Take the x on the other side of the equation.
But wouldn't negative 7 plus 7 equal 0?
You can see that that's not negative. Here's the x-axis.
Oh, so then it says negative x plus.
Yeah, but negative x would be equal to negative 7 if I do it that way, which makes x equal to 7. But the better way to solve this is to move the x over. Because when I take this negative x and I move it to the other side of the equation, it becomes positive automatically. So now I have 7 equals x, solved in one step, not two. In other words, there's nothing that says the variable has to stay on the left side of the equation. You move it to whichever side gives it positive coefficients is the best way to do it. In other words, by doing it this way, I introduced an equation that had two negative signs, which I had to get rid of, so I still get the right answer, which you're always going to get, but it's easier to make mistakes when you have negative signs. So whenever you're deciding to move your variable to the left or the right side of the equation, what you want to let influence that decision is which side will it have a positive coefficient instead of a negative coefficient. And for example, let me give you this problem here. 3x plus 1 equals 4x minus 3. Which side am I going to move the variable to, the right or the left?
You were going to be moving it to the right.
Yeah, because that'll leave it as positive x. If I move it this way, I'm going to end up with negative x. So whenever you have a choice, and you always do, there's nothing in math that says that x has to be on the left side. It doesn't. You move it in the direction. Notice that if I move the x's that way and the 3 this way, I get my answer immediately. X equals 4 in one step. Whereas if I do it the other way, I got to do 2 steps, because now I end up with negative x equals negative 4, and now I got to divide both sides by negative 1 to get x equal 4. So this is a 2-step solution. That was a 1-step solution. And you generally want to do equations in the quickest manner possible. Okay, in other words, if somebody says, do you want to do it in 3 steps or 4 steps, without telling you anything, you're always going to say, I want to do it in 3 steps. Okay, you never want to do something that takes more steps than necessary. It'll still give you the right solution, and it's okay, you won't lose points on it on a test. But I'm just telling you that when you have equations and you have a choice as to which side to move the variable to, try to move it to the side which is going to leave a positive coefficient.
Okay.
So this point right there, whoops, must be 7, 0. That's that point right there. When y is 0, x is 7. Okay, what else you got?
Y equals 1/2 x plus 3.
Now, what are we to do with this?
For one thing, y is already going to be 3 because it gives us that.
So this is the function. What other information do they give you?
That's it.
What are they asking?
To do the same thing, graph the linear equation and identify the X intercept.
Where do we start?
By graphing, putting down the 3
right.
as y.
We always, whenever you have an equation that's in y equal mx plus b format, you always start at the b.
Yeah.
Okay, so that's 3. We know that point is on the curve. And now how do we make a slope of 1/2?
by doing the same thing that we did
Which is what?
in the other problem, which is for every one you have to go 2.
So you go up 1 and right 2, right? So up 1 and right 2 is about right there. Now notice I actually had some choices. I didn't have to go up and to the right. I could have gone down and to the left. In other words, if I go down 1 and left 2, well, I get the same line. It's going to be the same line. So when you're doing slopes, there's more than one way to do it. You can go down and left. You can go up and right. You can go up and left if it's a negative slope. So up and right is the same as down and left. That's the key. Okay, let's extend this all the way to there. So they want to know that point there. So how do I figure out that point?
Well, for one thing, it's going to be -2.
Nope. What do I have to do first of all to figure out that point? What's y on that point?
Y is going to equal
Say it.
0.
0, exactly. So I can replace that y with 0 and solve that equation, and that's going to give me the x value. Okay, so let's do that. In other words, I replace the y. I'm going to make y equal 0, which I know that it is on the x-intercept always by definition. And now solve that equation.
1 second.
It's the first step for solving that equation.
Oh, sorry. It is going to be subtract 3 from both sides, and then you divide both sides by a half, and then the answer would be -1.5.
No, here's the problem. You want to divide both sides by 1/2? Well, that's fine. I don't really like doing that, but I'll show you exactly what that looks like. I'm dividing that side by 1/2. I'm dividing that side by 1/2. Okay, what's this number?
It's 3.
No. How do we divide by fractions? We flip the fraction and we multiply.
Yeah, oops.
-6.
Sorry.
That's okay. I want to go back here a second, and let's think of doing this slightly a different way. We're not going to divide both sides by 1/2. We're going to multiply both sides by 2. In other words, right now, that 1/2 is really x divided by 2, right? Well, by the principles of algebra, you always want to do the opposite. So if x is currently being divided by 2, then we need to multiply by 2, right? So rather than think of it as dividing by 1/2, think more of doing the inverse. That 1/2 x is the same as this, incidentally. Okay? That's 1/2 x. But more importantly, it's x divided by 2, which means to get rid of the 2, I'm going to multiply it by 2. And that's an easier way to look at it. Rather than dividing by fractions and then having to go in and figure out how you divide by a fraction, let's always just do the opposite of what it's doing. And it's very important to understand that 1/2 x means, in other words, this means the same as this. It's just that in this case, you would say x is being divided by 2. In this case, you would say x is being multiplied by 1/2. But the problem actually is a little simpler if you picture it as x is being divided by 2. Then you solve the entire problem with one step, multiplying both sides by 2. Well, what's that give you for a value of x? In other words, that half cancels out with that 2, So I'm left with x over there, which is my goal. I have minus 6 there. So what are the coordinates on this point that I've circled?
It is going to be negative 6, 0.
Correct. So, and this will apply no matter how far you go in math, is that when they ask you for x intercepts, you make y 0. Let me give you a slightly harder problem. If I said x squared minus 1 is y, and I want to know where the x intercepts are, then I make y 0, and I solve this equation. That's the definition. That's how you solve for x-intercepts, is by making y 0. If I gave you this and I said, what is the y-intercept? What would you do?
We made y the intercept. I would switch it out.
No.
And make
Y-intercept means what about x?
it means x is 0.
Right.
So that's what I was going to say. I was going to.
So all you have to do is substitute 0 for x, and then what do you get for y?
You would get y equals 1.
Yeah. In other words, when you substitute 0 for x, you end up with y equals negative 1. But very, very important concept. I want you to remember it forever. Y-intercepts are the reason that when I say y equal mx plus b, for example, y equals 3x plus 10, the reason 10 is the y-intercept is because this term always disappears when I plug in 0 for x. So this goes completely away when I plug in 0 for x. And what you're left with is y equals b. So that makes b the y-intercept always. And it doesn't matter, even if I have something like y equal x squared minus 10, well, the y-intercept is still that, because all I'm going to do is plug in 0 for x. Now, back to this problem over here, this quadratic. Here, let me erase one of these. So if I'm trying to solve for the x-intercept, I'm solving this, correct?
Yeah.
Next step.
You would add 1 on both sides.
Okay, that gives me that.
Equals 1.
What's the next step? Remember, I have to solve for x.
Divide both sides by...
Not divide.
Multiply both sides by...
Square root. In other words, always remember you're doing the inverse. Right now, the x is being squared. So to get x all by itself, all I have to do is take the square root of that. And since I took the square root of the right, I got to take the square root of the left. Now on the right, I get x. What do I get on the left? What's the square root of 1?
1, right?
Actually plus or minus 1.
Oh.
Always. In other words, if I say x squared equals 4, then x is equal to plus or minus 2, not just 2.
Okay.
Whenever you are solving an equation by taking the square root of both sides, always, always begin your answer with the words plus or minus, because an awful lot of students forget that, like 90%. Now, I know you're still on linear equations and you haven't gotten to quadratics yet, so this is still a little bit ahead for you, but remember that when you're solving an equation by taking the square root of both sides, well, the square root of 4 is actually plus or minus 2. All right. Logan, looks like you're on top of it. I will talk to you next Tuesday at 5.
Okay.
All right. Have a good week.